So can you briefly describe what exactly ETH 2.0 is and what is going to happen in this merge?
Hey, sure. I'll probably answer this question a little roundabout. That is, this is a common misconception that ETH 2.0 and the merge are in some ways related or are the same thing. So the merge is actually a part of a much larger Ethereum roadmap. So the Ethereum roadmap consists of a lot of things relating to the scaling of Ethereum itself. It started with the variable block sizes, which we saw with EIP 1559. Now we are talking about the merge, which is more of a proof of work to proof of stake kind of a switch. But that's not the end of it. That's not the end of. It's not like after the merge you're going to say, "Hey, Ethereum has scaled, and now gas prices are going to be really low." No, none of that. In fact, after the merge, I do not expect any change in gas fees because those dynamics do not exist here. But it's also part of a larger roadmap in which, to name a few, probably sharding is going to be a part, account abstraction, that is EIP 4337. Then there's going to be EIP 4844, which is like Proto Dank Sharding, then Dank Sharding. So a lot of things are going to come in. Like, what is it called? Sustainable storage is going to be a part of it as well. Account abstraction is going to be a part of it. So all of these things put together is what will unleash Ethereum scaling, and it's like a multi-year roadmap. So the reason that I am making this correction upfront is until very recently, ETH 2. All of this was branded under ETH 2.0, right? And the merge itself, which is like switching from proof of work to proof of stake, was supposed to happen after we get to sharding. That was the initial roadmap. But I think somewhere down the line, what the community has decided is to, hey, you know what, we'll do sharding later. It's a much harder thing to do, but we already have things in place for proof of stake. Let's do that first. So it's a gradual progression towards decentralization. And yeah, so ETH 2.2 does not even exist. In fact, Ethereum Foundation made a public statement saying that they're getting rid of that terminology. So it is just a roadmap of scaling. And it so happens that proof of work to proof of stake is one of those steps. And that is pretty much what is going to be happening around the merge. Of course, happy to go into more details on what the merge itself is, but just wanted to make this clarification, rectification upfront.
So I just want to confirm. So what happened exactly in the recent merge on the Tropston test network? Can you please talk about it?
Sure. So I think first of all, the merge that we are witnessing right now, or what already happened on the Robson test network, is the switch from proof of work to proof of stake. But in my mental model, this always begs the question: hey, if we are switching from proof of work to proof of stake, why is it called a merge? What are we merging it? Why is it not called a switch? Like a switching from POW to POS, why not call it a switch? Why is it a merge? So what exactly are we merging here? I think that's an interesting topic to dive deeper into. Um, so to give you a little bit of context, so Ethereum in general invented a new blockchain, right? So there exists one more blockchain out there called the Beacon chain. Beacon chain launched approximately end of 2020, if I'm not wrong, and it has been running ever since. So what the Beacon chain essentially does is gives us the first stepping stone towards moving to proof of stake. So right now, Ethereum is built on proof of work. Proof of work is essentially, hey, there's this node, and the way that they all come to a consensus is any node that is able to mine, right, a particular nonce that satisfies a particular equation, they're allowed to propose a block in the blockchain, right? So the way that we choose who gets to propose a block is defined by mining, and that is what is called proof of work. So that's how we come to a consensus in the proof of work network. However, what Beacon Chain is doing is saying, hey, you know what? I don't want you to be solving all of those complicated equations and finding a nonce and doing the mining because that is wasted computation. Instead, I will tell you who is supposed to present the next block. Right? So no need to do all those computations. Just trust the beacon chain. So the beacon chain basically says every, I think, 12 or 13 seconds, it'll say, hey, you know what, Sai, you are the next person, propose the block. After another 13 seconds, it'll say, hey, Aniket, you are the person who should be proposing the block, then Madhavan and whatever. Right? So that's essentially the, excuse me, that's the beacon chain. Right? So the beacon chain is replacing the need for doing mining and replacing it with just assigning people on the fly as to who should be providing this um, the next block, and that's how we generate the blockchain. And this form of consensus is called proof of stake. The reason that it's called proof of stake is who gets to propose these blocks. So if the beacon chain is saying, hey, Sai, you should be proposing the next block, it is picking Sai um, based on a probability that is proportional to how much money Sai has staked. So basically, you can come in and say, hey, you know what, I'm going to put in 32 ETH to provide more security to Ethereum. And if Aniket comes in and says, hey, I'm going to put in 64 ETH to provide security to Ethereum, Aniket is twice as likely to be picked as the next block proposer as compared to Sai on a probability scale. And yeah, like if you're the person who is proposing the block, you also get the block rewards, right? So that's a strong incentive to be picked as a block proposer. So and if Aniket or Sai or Madhavan or anybody is misbehaving and compromising the security of the chain, the stake that they put in, the 32 ETH that you put in, or 64 ETH that you put in, will slowly get slashed. Like for each misbehavior that you do on chain, your stake gets slashed. And in the assumption that if you are if you care about your money, you will be acting honestly to make sure that you do not get slashed, and that is where the name comes in, proof of stake. Like you putting in a stake, you're not putting in work as in compute that is done in proof of work. You're putting in a stake, and that stake determines the frequency at which the beacon chain picks you to become a block proposer. And so these are like two things that exist: the proof of work and this beacon chain. Now,
Got it.
what the
So,
merge is doing, yeah, sorry,
so sorry,
I'll
Madhavan,
just wrap this
continue.
up. Yeah. So basically, what this merge is doing is merging these two. It's saying, hey, you know what, proof of stake, you bring in all your computation, right? So you are already doing the validation of transactions, making sure that there's no double spend and stuff like that. You bring that in, and the proof of stake will bring in the beacon chain. So the same execution layer of proof of work, which is called EVM, and the consensus mechanism is replaced from proof of work to proof of stake. And these two things are merging, and that is what the merge is about and likely to happen in September this year.
Wow, that this is like very good explanation around proof of stake and proof of work. Got it. And you said that it's I mean the validators are picked randomly based on the stake I do have. So
Mhm.
is it only based on the stake, or like do we have any algorithms that randomly picks the validator to validate the transaction? I mean the block.
So, happy to go into more details, but at a very high level, it is random, right? So now the question becomes, how is it random, right? So now there does not exist a purely random function in the theoretical sense. So there is some source of randomness that is coming in. Where is that coming in from? Becomes the next question. So there is something called the RANDAO, which is a part of the beacon chain, which determines what that uh, in computer science terms, what is the entropy of the randomness. So how are you defining the random number itself? How are you defining that random picking of the validator is yeah, kind of dependent on what the RANDAO presents.
Got it. Yeah. And also you spoke that ETH merge is not guaranteed that like your gas price will go down. So can you elaborate more on that? Why the economics of the gas prices won't affect with the merge?
Yeah, for sure. In fact, I can rephrase that to a more stronger statement. That is, there is going to be no difference in the gas price because of the merge. And here's the reason. The reason is the execution layer is still the same. The execution layer is still the same EVM as we have on proof of work. That is not changing after the merge. If you remember, what are the two things we are merging? We are merging uh, the consensus layer of the beacon chain and the EVM machine of the proof of work. These are the two things that are merging. So the execution layer, the block sizes, the transaction fee per block, everything is the same. So the demand for block space is, let's assume, not changing, right? Before and after the merge. If you assume that the number of people who want to have their transactions included is the same, the supply is also the same. Block space, the amount of space that you have in a block has not changed and is not going to change after the merge. So if the demand is the same, the supply is the same, that's likely going to be no movement in the economics or thereby the gas prices. So I know that this might come as a surprise to a lot of people because the entire narrative around Eth2.0 has been that we're going to scale, we're going to make transactions cheaper, and so on. But that has nothing to do with the merge. All of that is probably in the future, right? So probably something like sharding. Sharding is likely to reduce transaction fees. Happy to go into the details of that, but the merge itself, in which we are bringing the proof of stake beacon chain and the EVM execution layer together, in that it would be unwise to expect any changes in gas prices.
Got it. And now you said a new term called sharding. So what is sharding is all about?
Sure, sure. Hmm. So sharding is also a very, very loaded term. It's also, it used to be a part of the larger ETH 2.0 roadmap. But however, the definition of sharding has also evolved very, very rapidly. So I'll probably start with a little bit of history and improve the model as we speak. So initially, the concept of sharding started with um, hey, there are like millions of transactions that need to be executed, um, and every single transaction has to be validated by every single node on the Ethereum ecosystem, right? So that means if there are 200,000 nodes, I think that's the number right now. There are 200,000 nodes. Every single transaction is being executed 200,000 times, which seems to be wasted computation. Rather, what sharding says is uh, instead of having 200,000 nodes evaluate every single transaction, maybe have only 200 of them evaluated, right? So break it up into 1,000 quote unquote shards, in which only a limited number of computers are required to process a single transaction, and thereby being able to scale the entire number of transactions that Ethereum as a whole can handle. This was the original. This model that I just explained is what is called as full sharding. Right. So full sharding is in which the transactions itself are being executed by subsets of the Ethereum nodes. Basically, what the full sharding roadmap was, hey, all the transactions that are being submitted to Ethereum is going to be validated or computed on every single machine. So how can we break that down into shards? So instead of 200,000 nodes executing every single transaction, can we have only 200 nodes executing one transaction and then build some kind of a consensus on top of it so that they eventually come to a consensus? So that's kind of the full sharding model in which all the transactions are being executed within shards. However, that ever since has kind of lost momentum. Rather, what we've moved on to is a more roll-up centric roadmap that Vitalik has presented, in which we are saying um, instead of when there's a roll-up, right? So whether it's a ZK roll-up or an optimistic roll-up, there's a lot of data that is being generated, and that data is required to be able to provide the security. Like in the case of optimistic rollups, you need you need fraud proofs. In the case of ZK rollups, well, you need the ZK proofs, right? All of that needs to be stored somewhere, right? If it is not stored somewhere, the security of the L2 is being compromised. So right now, all of that data is being thrown into Ethereum, right? So that becomes inefficient. Now, every single piece of data that Optimism is throwing onto Ethereum is being replicated on 200,000 machines, which is not required. Like fraud proofs happen once in a while. I don't know if it has ever happened on optimistic rollups yet. I think they have not even enabled it. So let's assume fraud proofs are rare. So it does not make sense for us to store all of the information required to generate a fraud proof on 200,000 machines. Like 200,000x replication is not required. So we can split the data into smaller pieces by putting them into shards, saying that, hey, you know what, we don't need 200,000x replication. We need only 200x replication should be good enough. So yeah, and using a few more optimizations, you can bring that number even lower. The process is called data availability sampling. If that is put into motion, which is what Proto Dank Sharding is about, you can get much more benefits of being able to store the data from an optimistic rollup or from a ZK rollup very, very cheaply onto the Ethereum main chain, thereby giving L2 the security that it deserves, at the same time drastically reducing the price of providing the fraud proofs and the data required to generate them onto the main chain. So that's essentially what sharding does. Takes optimistic rollup, takes ZK rollup, and whatever data that they're creating, splits them up amongst all the nodes and stores them for perpetuity. And
Got it.
that
Now
is
it's like
where,
there is no necessity.
yeah.
Yeah, yeah, go.
Yeah, now because of sharding is where you can expect benefits in gas prices, because it is much cheaper for Optimism to store data on Ethereum, and also all the execution is being pushed away from Ethereum onto L2s, which is of the order of 1 to 2 magnitudes cheaper than the Ethereum main chain. So that is when once sharding is into motion, even with proto-dank sharding, which is the earliest version of sharding that we can expect, you can expect significant drops in the gas price. But till then, gas prices are not going to get affected.
Got it. So as a node validator, I need not to like replicate every other information on the blocks. So I just need to validate one particular shard and that's it.
That is correct. Once in a while, call the epoch, you will have to do some computation that will help you bring consensus across shards. But for 90% of the time, what you said is absolutely accurate.
Perfect.
Yeah, Madan, actually, you mentioned that the 200K nodes or validators will be converted, like the shard can only have like 200 replications. Is this also selected randomly, or how does it work?
Yes, yes. So this is also this is a part of the beacon chain conversation that we were having a little while earlier, in which the shard of a particular node is also going to be assigned randomly by the beacon chain. Um, yeah, and that's an elaborate ceremony that happens called committee and attestation. So for yeah, basically, the beacon chain determines which shard you are going to be evaluating for the next few blocks.
Got it, got it. Actually, like we are going very technical in this, and I had a question around maximal extractable value or minor extractable value, which was called, I guess, in proof of work. Like I'm very naive in this. Do you have
Mhm.
like a very brief understanding of how this can be explained?
Sure, sure. I can try to explain you this question in both the standard world because this has like an impact on sharding, and the beacon chain. So I can get into the specifics of that also if relevant. So broadly speaking, what MEV stands for, minor extractable value, is that you can if you are the miner on the proof of work network on Ethereum, you are seeing all the transactions that are happening, right? Like or that are going to get included. So while you are creating the block, just by rearranging the transactions or including transactions of your own in between a couple of transactions. So let's say there's somebody who is willing to sell um, uh, some particular token at, let's say, $1.2 at a maximum of $1.2. And you are seeing, because you are the person who is creating the block, that, hey, you know what, at this point in time, the price is actually only $1. So you can put in one more transaction in between, which is your own transaction on, let's say, Uniswap, and say, I'm going to exploit that $0.2 difference, right? Just because you have information of what are the transactions that are going into the chain or into the block, and you know what order that they're going to go in as, and you have the luxury to create new transactions on the fly and insert them in between. So using these three tactics, there is some money, in fact, a lot of money that you can make by using this mechanism. This is what is called minor extractable value. Um, and depending on how you look at it, it's a huge problem or like a huge incentive for the miners to, well, participate in the process of mining. Um,
Yeah, would this also like be a place where a lot of Uniswap running bots and all these things are done like via actually running a node and trying to understand what transactions are happening?
yeah, 100%, 100%. So in fact, front running came out of MEV, right? So now, uh, or I would say, front running is a form of MEV. So yeah, definitely they are related.
Got it,
So
got it.
nowadays, what is also happening is people like Flashbots are providing this as a service to miners,
Oh,
saying, hey, if you're a miner, you don't need to worry about what is the MEV you can extract. You can subscribe to Flashbots. Flashbots will keep telling you what are the MEV opportunities available by running their complex algorithms, and provide that as a service to miners.
got it. Any specific tools like you know of which people use?
Flashbots is the most popular.
Flashbots. Okay, okay.
Yeah. But this
Got it,
thing gets
Madhav.
even more exciting in sharding. So I don't know if I touched upon it, but there's something called Dank Sharding that is going to happen before sharding, before full sharding. And Dank
Mm-hmm.
Sharding essentially is a way to incentivize more MEV to happen. So there's a separation that's going to happen between block producers and block validators, essentially making this flashbots like marketplace a part of the protocol itself rather than out of protocol mechanism.
Got
So
it. Now
Ethereum
you
is
that
trying to go down the
mentioned.
line of, yeah.
Got it. Now you mentioned two terms: block producers and block validators. So how are they different? How they function?
Yeah, so block producer is in the context of um, Dank sharding, is that the block producer is always trying to look for MEV opportunities, right? Which is a very, very computationally heavy task. Like you have to run multiple servers, try to identify all of these opportunities, run multiple strategies, and do some fancy stuff. So that is something that you probably cannot run on your mobile phone, right? So basically, what Dank sharding does is it separates out the person who is creating the block by doing all of this MEV mining, and then there is a validator who is just going to pick a particular block from the marketplace and say, "Hey, I'm attesting this." So it's very, very cheap to run a validator. So once you pick a block from a block producer, you can quickly verify whether all of those transactions are valid. If they're valid, you just propose that. So basically, it's
Got
like vouching. Right? So I vouch for this particular block, and I will get some rewards out of it if I um, yeah, become the block producer. So yeah, that's how these two are different. So block proposer is a very computationally intensive task. The block validator is a very cheap task. So yeah, separating out these two concerns also has multiple downstream effects as well, because of which this separation was being made. Happy to go into those details
Exactly.
also
So
if required,
will
but
both
pretty
parties get
technical, yeah.
incentivized for validating these transactions?
Yes.
Oh, nice. And
So
what would be
the
the
block produce.
yeah? Go on.
The specifics of the parameters are still under works. So this whatever I'm describing is going to be part of Dank Sharding. Dank Sharding is still in the future. We will get to Dank Sharding only after we implement Proto Dank Sharding. So even Proto Dank Sharding is significantly far into the future, at least a few months away, if not years. So the parameters of, hey, what is going to be the split between a validator and a block producer? What is the incentive for each of them? I think those are questions for a much later date.
Got it. I think today's session was pretty elaborative, and also I got to know personally about many things that I didn't know about.